too deep for our presenter.
Yeah, I want to basically learn. Okay, here's the geek stuff and last question. Otherwise, I give a talk on Multitions listen to. I'm amazed at the people spend time multi-simulating.
A lot of old code, right? You got to be able
Well,
to run.
it's half a century. Multi MSPN. Like,
guys, I think that
John, how you set?
Well, I think it's
is
working.
the lost in action?
okay, I think I usually start the speaker around quarter after. Let me get a quick show of hands. How many people are planning at this time to go to the Cambridge Brewery?
The same number.
Okay, 1, 2, 3, 4, 5, 6.
For those of us not
7,
know what usually happens
and maybe
at the
2
Cambridge
extra.
Brewery other than
So
people
maybe
drink.
9. Excuse me?
What usually happens at the Cambridge Brewery other than people usually drink?
This crowd, well, with Kurt, you're going to get beer or ale. But this crowd generally doesn't drink much. I drink coffee, he drinks Diet Pepsi.
We'll order food over there,
And,
just conversation.
Steve drinks lime, Coke that he brings with him, and has had arguments there before. Just to get rid of them, they do. So basically ask people about the time we're leaving, so I get a good idea of how many people are coming.
Just so you know, the rules are that user groups are that usually you talk money at somewhere else other than make group. So they purposely have dinners for discussing money later.
John's too busy with his Nexus. Yeah. And he loves his Nexus 6.
I'd really like to tell people in IRC to go with the link to the IRC for the last
Hey,
page.
John, after you showed me the Google Fi out at the barbecue, I'm inclined to think it's gonna work out really nice.
Yeah.
I like what it's doing already.
Yeah, I think right now Google Fi is nice. They've got 2. They're actually using T-Mobile and Sprint for their carriers. But for you paying $35 bucks a month for Google Fi.
I thought he said it was 30.
It's 30,
It's $20 a month for unlimited voice and text, and $10 a gigabyte for data.
which is 10 times as much or much more than the other train.
Okay. Well,
It's still a good deal. I just want to see the hardware improve a little bit before I move
Okay.
on that way. I've read
what do
some
you mean the
things
hardware?
saying the Nexus, the phones themselves
Yep.
aren't like this. Yes, but they can be in the future.
Okay, and it's a fairly unlocked system too. Okay, we're about ready to start. And Kurt, are you going to be the first guy?
Yeah, I'm doing the history lesson.
Okay, Kurt Keville is going to give us a history lesson. And take your notes. You will be tested by Brian.
So OpenWRT is a rather broad and deep subject, so we'll be treated as superficially as we can here. And then Brian will talk about the contemporary OpenWRT topics. I'll talk to you about some of the history and why it went the directions it went. So, so I've been at MIT as an employee for about 20 years. And every morning, Monday through Friday, I get up, do the same regimen. Get ready to go to work, grab a cup of coffee, walk out to the elevator in my building and hit the button. And every now and then I look down and discover that I'm not wearing any pants. So I'd say that's probably happened 3 or 4 times in the last 20 years. But I know the root password for MIT RoofNet from 10 years ago. So I may be suffering from early onset Alzheimer's, but I remember the important stuff. So this is where it all started for me. I don't know if you guys know a guy named Tim Shepard, but he got all many of his degrees from MIT. And he, in the early days, Dave Clark was his PhD thesis advisor. Parsed through the 802.11, the IEEE 802.11 pre-spec, and found some interesting gaps in it that he thought we could capitalize on with some subband. I don't think they even specified that ad hoc was a mode back then, but he found some interesting things that you could do with 802.11. And it started getting implemented. 802.11, for those of you who were buying wireless access points on a regular basis, you get something from a working group that was 802.11n or S or something like that, or it was pre. And then you'd get it, and then the IEEE working group would change the spec quite a bit. You'd find out that yours wouldn't talk with other 11n devices. One of the great things about OpenWRT for us, when we were banging on it, last decade and the one before, you could make your modifications to software. So when these modifications to the spec would come out, you could test them out and do your net pipe and your tests and change it after. So you didn't necessarily have to sync a bunch and go on some firmware and then have to retire it. If you guys want any non-spec routers, I have stacks of them.
Do you have any WaveLAN routers?
Let me look through the pile. Yeah, I have tons of antennas too. So it's like 2.4 and 5 gigahertz. So 100 megahertz.
One microphone?
Oh yeah. So Cambridge Public Internet Project came out of the fact that City Hall in Cambridge, they had talked to their fiber providers, and they had 2 or 3 from some initiatives in the 90s. They said, hey, can we? We're not going to resell this bandwidth that we're buying from you, but can we give it away for free? And that appeared to be part of their terms of TOS and their EULA, and that worked out well, because simultaneously to what MIT was doing with ad hoc mesh work, Matt Welsh, who literally wrote the book on Linux, I think we've had him here.
We've had him here.
Him and Laura Kaufman was a faculty at Harvard, and he had gotten a grant to do this CitySense work, and he was the PM of all of the traffic lights and street lights that they had in his part of Cambridge. We all worked out a deal with the City of Cambridge. So Cambridge owns its own street lights, and there's power up at the top all day long. It doesn't wait to dark to have a switch that turns on. So he put together a node. You can go to citysense.net on archive.org. There's nothing there right now except someone trying to sell the domain, I think. But there's all sorts of interesting stuff at archive.org. And we all agreed that we were going to have some variant on OpenWRT as our base, so that our packets could jump through his APs and his packets could jump through MIT's. And MIT's installed, I don't know, maybe certainly from my part of it, and I was only one of 5 labs that was out there installing Cambridge Public Internet, maybe 500 nodes that I personally oversaw getting installed. The pieces that MIT installed were at the housing projects. So we worked with the CHA. The first housing project we did was Newtown Court, because it had line of sight out of the building that I'm in. And there's another couple of these. So out of the 10, 20 tallest, or out of the 20 tallest buildings in Cambridge, the city or Harvard or MIT or Volpe had like 10 of them. So we could go over and say, hey, can we put up one of these RoofNet, call them sinks? Can we put a sink at the tallest point on your building? And Volpe was fine. They let us go up to the top, and we put up a big 2.4 gigahertz, I believe maybe just the 12 dBi antenna. So this was kind of a typical Cambridge Public Internet node. So the RoofNet folks over in CSAIL, over in the Parallel Distributed Operating System, who kind of like these Netgear WGT 634Us, because it was very easy to flash OpenWRT in them. In the early days of OpenWRT, you'd go out, you'd buy a WAP, and you'd pop the plastic off, and you'd find out if it had like VxWorks or Red Boot or some goofy, bootloader in there, and you'd flash OpenWRT into it. And there's a how-to on some of the more difficult boards in the early days, the SPHIA soft boards or whatever, kind of tricky. But they showed you how to make a cable if you didn't have Ethernet, and kind of getting ahead of myself on the slide too. But certainly the Netgear stuff was this was very easy to work with. In particular, the Broadcom, this was kind of a Broadcom reference design MIPS board, and you could pop out the 11B only radio and stick in a really nice Ubiquiti radio. So Ubiquiti sells any kind of radio you want. You want 3 different channels in there. You want, multi-spectrum. You can get 900 megahertz radios. You can get almost anything from Ubiquiti. Remarkable company. Usually with MMCX connectors. So we made these 12 dBi antennas. We bought a cheap bunch of Primestar boxes off Just Deals, and we started sticking them up all over Cambridge. And it worked swimmingly for a while. We had, for certain Cambridge-owned buildings, there was some problem with roof penetrations, and then we started getting clever about just getting the open mesh or the Meraki style squeegee things and just sticking them into windows. So like at Newtown Court, there's kind of a big corridor where we had sinks, and anybody who stuck one of these things in their window would just get signal. They'd stick their computer that they were getting from probably the Pisani Center. They'd stick Ethernet into the box, and they'd just get internet. And the way we fielded it, there was no particular filtering or anything like that. They ended up going with a captive portal system, and I think that'll be more in Brian's slides. I'm just going to talk about some of the early fielding we did, and I thought we did some pretty innovative stuff that has become conventional. Certainly, polling the various devices and virtual APs and what have you that were built into RoofNet, so that if you did stick Ethernet in, it would know that you were basically pivoting from router mode to, so that you wanted a signal. If you stick this guy on, I have a couple of these on the air back in my office, just so that I could make sure they had static IP addresses. If you stick this on and plug it in, stick it into Ethernet, it'll find out whether or not it can get a DHCP address, and then it'll set this up as a proper access point. If not, it'll set it up as a bridge, I guess. So the 3 boxes I'll let you in after I let Brian do his presentation. So I've got an OpenWRT version 1. OpenWRT distros are named after vodka drinks. It's like Backfire, Kamikaze, White Russian, and so I think I've got one of each versions. So you guys will be good and thirsty. You can only get beer over at the CBC. So we did this. There was a lot of work at that time. I was the MIT guy of the Cambridge Public Internet Project. Matt Walsh and a whole bunch of UROPs, MIT UROPs and Harvard REUs were working on CitySense. They did some really remarkable stuff and fed it all back into the community. The term WRT comes from that first Linksys product. I think it was WRT 11 maybe when it was just when 802.11b. 11b, the working group moved a lot faster than 11a. So 11a was still in design status for quite a while. 11b products were all, as you probably remember, we had them 5 years before 5 gigahertz products were out. That sound about right, Ruff? For some reason, I mean, even though 11a was certainly thought of before the 11b products, we were in 2.4 gigahertz for quite a while. It started getting crowded there. 11b didn't handle, channel allocation quite as good as G and S and N, some of these the other working groups. Then Ubiquiti was coming out with radios that you could get, you know, both the 5 gigahertz and the 2.4 gigahertz on. It was a good time to experiment. If you had boards like this, that you could swap out radios when they came in. Ubiquiti really found a way to capitalize on the FCC spec. You know, you can get if you build it right, you can get a watt out of these Ubiquiti radios. The stock, we're only getting 250 milliamps out of some of the Broadcom reference designs. But you know, 12 dBi antenna. We were looking for radios that had good receive sensitivity, and you know, and to a certain extent, you could dial the power up to the legal maximum, the FCC Class B.
What kind of flash memory do you have on there? How big is the memory?
So I have a slide of that. These things are about as tight. When you flash OpenWRT into it, it's a really thin distro and just barely fits. But this was an 8 meg board. Everybody else had 8 meg of RAM, and everybody else at the time had 4 megs. All the Linksys products were 4 megs. So this was like ridiculous. Yeah, you thought we had room to burn. So Aruba. So a lot of the work I did was with a guy named Mike Kershaw, who ran Kismet Wireless, and he liked host AP and Prism 2 drivers and things like that. Well, as soon as OpenWRT became popular enough that everybody was buying Linksys and Netgear and D-Link products and flashing, you know, Linux and OpenWRT into it, Aruba hired him and Mike Baker and some of the other folks from OpenWRT. So the Aruba products had a really nice feature-rich version of OpenWRT as well. I'm going to tear through this just so that we get back on schedule. Earlier versions of I don't know anything about Tomato, so I know there were lots of competition to OpenWRT in the old days. But some of the concepts that being able to set up, you know, 8 different APs, some of which were broadcasting, beaconing, and some of them weren't. So I know there's a lot of consensus on what makes a good distro now. And certainly the Wi-Fi stack, a lot of people pretty much agree on that now that, you know, with the success of Meraki, how you put these things out in the field and how to make them adaptive. The TP-Link stuff, we saw some TP-Link stuff that was just incredible and very robust. You know, you find the AP or it finds you, and you know, not in the old days where you had to take a wild guess at like what your DNS server was, and so and maybe at the end we could maybe compare and contrast Tomato. I don't really know that well. I've seen all these other ones in various incarnations because we had some boards that we just couldn't get early versions of OpenWRT into, so we tried DDWRT and some of these other slam boxes.
Aren't Tomato and DDWRT still at least semi-active in terms of development? I believe.
I think DD's somewhat deprecated. I don't know.
Have you heard of something called as Dan's Guardian? It used to be a router firmware which had controls on how to kind of control your plans. So like what websites to control and that kind of stuff.
And what was it called?
Dan's Guardian.
Yeah, I'd like to look at that. Yeah.
I think I heard something. I think with that name. I think it was a HTTP proxy system rather than a router so much.
Yeah.
And it had security controls and access controls used in school environments where you want to control what students can gain access to on the internet. But it wasn't specifically Wi-Fi. I think it was an HTTP proxy.
I think it proxied more than HTTP, but yeah, that's what it was. I believe is that it was basically a proxy type system thing.
We actually had a guy here from the 802.11s working group. I think we had a couple presentations while this stuff was still in flux, and we had a representative of the IEEE group here, which was pretty cool. We asked a bunch of questions. And my versions of OpenWRT use iPackage as the package manager, which is workflow like apt. You set up a little sources.list thing, and you can bring in. If you've got room, if you've got a whopping 8 megs on your board. We'll wait on Brian on this. I think this has also been, there was a lot of experimentation with different ad hoc routing, but I'm pretty sure about going to convention now. I've got some OpenMesh slides. The OpenMesh seems to be seems to have taken a big part of the market share now that Meraki. I don't know how much of a market share system Meraki has. At one point, there were tons of Meraki nodes when Meraki was some company in San Francisco, and I can't speak for very many other towns. But like I say, the high watermark of Cambridge Public Internet, we had a lot of density in the housing projects. You know, there's Washington Elms, Roosevelt Towers. There's a lot of housing projects in the city of Cambridge, and all you really had to do was go down to the main floor at Newtown Court. It's the design center. That's where they fix the broken computers. That give you what ended up being an early Gen 1 Meraki node. It will squeeze you on the sticky on the back, stick it in your window, and you get the signal. And the other, everything else ended up being very much of a subjective wire run or truck roll or something. You know, you'd have to. Somebody would say, "Well, I'm a textbook case. I've got this window that faces out to the courtyard. Why can't I get a signal?" And maybe we'd have to fix it. But it was helpful. You know, it figured out what parts of this, what part of it. Radio just kept getting better, so that improved. So these were the previous rooftop WLAN presentation. I think Lenny Foner from DataSnet might have been in 06, 08, and 09. And then most of the MIT roof and Cambridge project went away. There's still plenty of functional nodes out there. They're just not really gateway. So if you lose one of the nodes that you're jumping through, there's a pretty substantial degradation. So I have a couple slides here, but like I said, they're not that topic. The Mesh plus Star is robust since we would do an agnostic fielding. We just put our gear where we had roof ranks. We do we fix the dead spots. We call it agnostic fielding on mission fixing or something. So we fixed the dead spots with 5 boxes.
So in the project like this is a distribution from one point. It is a build architecture to permit you to get other sources of connectivity. So people can contribute additional connectivity.
Yeah, and RoofNet would know and reorder the routing tables if someone plugged into their service provider and became a sink instead of
became a source.
As a jump. Yeah. So and that worked out pretty well. The ratio of deadbeats to provider were like 10 to 1. And you know, you'd get a signal sometimes 3 or 4 hops on the road, and it was still a signal. It was better than nothing. Considering that the vast majority of the customer base was getting a free AP that either MIT or the city of Cambridge bought, and they'd use it until it stopped working or until they lost. A lot of them were getting laptops from the school system, so that combination was, that's all they needed to do their homework at home. I'm sure they were using it. We tracked for a while. We tracked bandwidth use, and there were a lot of people watching Vimeo and whatever early YouTube back then. But it was, we'd go around and we'd fix the.
What I'm trying to understand, this is more of an offline discussion. It sounds like there's something off about the policies that didn't create the right incentives to sort of make it the standard for connectivity, but that's a more detailed discussion.
Yeah.
The other general question, there's just sort of an obvious one that's not there, is what is OpenWRT in the sense of what is the separation between what is Linux and what is all the root or add-on stuff?
Yeah. So, and I'll certainly log in while Brian's talking. I'll turn on a couple of these nodes. Everything, so it seems to me that OpenWRT represents a spectacularly high percentage of the wireless access.
No, but I'm saying, but technically.
Yeah, so.
In other words, if I do a diagram of WRT Linux, is it an app on top of Linux? It is different drivers in Linux?
No, so.
It's a Linux distribution.
Yes.
Yeah, so
But
I'm
how
using
does it differ?
2.6 kernel on my version of OpenWRT, and mostly a superset of BusyBox. So you can type in the standard network commands. It'll all be there. Linux file system, proc file system. Yeah, I mean, a lot of recognizable stuff. iPackage is a little bit quirky as a package manager, but otherwise.
So this is a main part of my value. So you're saying Linux in general has all the stuff it takes to be a router. It's just OpenWRT, that's really the stuff that's not necessary.
Yeah, and it's replaced the TCP/IP stack. So when you do an if config on these nodes, you'll see 8 to 10 devices, most of which are virtual. So yeah, and so this was my SPOF event. This truly encouraged me to go out and get a RoofNet node. I had been buying service from TowerStream, and the TowerStream antenna got hit by a lightning bolt on the top of the John Hancock building. And I got to take my hat off to TowerStream. They rolled the truck as fast as they could, but I had a classic definition of a catastrophic outage. And I'd much rather have 1/10 of the bandwidth I'm paying for than 0% of the bandwidth I'm paying for. There's something just absolutely terrible about catastrophic outages, even though, you know, TowerStream ran out and flipped this pretty quick.
And your old modem didn't happen.
Well, and so the TowerStream terms of services. Are you guys familiar with TowerStream? It's kind of is it a WiMAX that they offer? Yeah. So they said, oh, okay. So well, our end user license, we'll just give you additional time, like were you out for 2 days? Well, we'll add 2 days to the end of your contract. So it's like, okay, I'll tell my customers that. So this is the RoofNet would go around. The two guys that started Meraki were RoofNet grad students. They were working on their PhD, and they got a grant. And if you were an MIT student, you could get a RoofNet node, and you'd stick it in your window. So this was pretty much an agnostic field. No installers went out and made sure that the omnidirectional antenna was pointed in a particular direction. So they had crappy fieldings. You know, some of these ones that are red and orange are bad signal. But you know, it was a good test bed. You know, a lot of this stuff, they said, well, we've got some blind nodes that we'll recover, but for the first fielding, for the first couple of dozen nodes, that was a good test. That's about as they knew you had to be living in this neighborhood somewhere. And they said, okay, well, there's going to be some people that get much more traffic than others, and maybe we go in and we give them better radios. So this was a good experiment for that test. And this is a typical MIT RoofNet page. You get into this and you stick your WAN connector in, and you can log into this via the WAN connector. It'll get an 18.2 address if we do it here, which we will, but I've already got some online. You can talk to it if you're sitting there with your wireless access point. You can talk to it across the ad hoc mesh if you use this Net 5 stuff that RoofNet boys were allowed to develop with. I understand Net 10 is routable now. You guys hear about this? Yes, they're so desperate for static IP address that they yanked 10.x back. So
They took it back?
yeah.
So it was?
Yeah. I don't know if they've handed it out yet, but I heard Ayanna or Aaron, whoever controls the
Static IP address is such a bad idea.
All right, so I'll show you some of these.
I'm going to be surprised. That would not be astonishing to see lots of things break with.
This is true, like RoofNet.
Say, didn't they announce that back in April 1st?
Maybe that's where my.
They're not gonna take my Class C out of my cold hands.
Okay, so there's some great work on ad hoc mesh development, mostly around OpenWRT and Seattle Wireless and Portland, but there was a ton of it going on here because we were also highly motivated to find a good distro and manage our ad hoc mesh so that we could just stick it in our window and get free internet service. I had a RoofNet node maybe 10 years. The quid pro quo was the developers could do anything they wanted with it during the day, 9 to 3 or something, whatever an academic day was. And at night, you could use it for whatever you wanted to. So you had Ethernet coming out of your thing that was pointed roughly in the direction of some other antenna that was relaying a signal to you. So I probably had, my routing table certainly had the limit of 50 nodes that you could talk to. So I was probably seeing, pretty close to that, maybe 40 nodes, and getting great signal. And it was all we had gigabit Ethernet at MIT. So if you were primarily getting your wired connectivity from MIT, you were getting a great signal. Because keep in mind, this was, 802.11b back then. Nobody was getting 54 megabits per second. Not for the early days of RoofNet. And eventually they were, especially after you swap the radio out with a good ubiquity radio. We owe a debt of gratitude to some other non-Massachusetts groups. They were pretty far down the road on this in Berlin. Sasha Meinroth, who works at newamerica.org, had his competing version. Here again, it's a Linux distro on a commodity wireless access point, of which there are thousands. If you look at OpenWRT table of hardware, I'm sure you'll see something that you have sitting in your attic in that list that you can flash OpenWRT. I don't want to take too much from Brian, and it's going to take me a little while to set up my my nodes anyhow. These are some really old photos, or old, I think this one was like a Skyhook war drive. Brian and I did a war drive of Mem Drive when we wanted to provision the solar wireless mile, and maybe he's gonna. So I got lots of good war drive shots. This one had the ranges superimposed on it. This was kind of.
What was the time frame of that?
Oh, the other one?
Of the war drive?
Oh, so we did almost all the important parts of Mem Drive, which is the far edge of MIT to the far edge of Harvard. It's probably a 5-minute drive, but we captured almost everything. I mean, we had a good radio, we had Kismet wireless. So we're just sitting there running Wireshark.
Is that 2009, 2010?
No, correction, 2007 at the latest. Yeah, so it was kind of surprising. So we found a bunch of, we wanted to give free wireless away for the regatta, and we were literally on the other side of Memorial Drive from Sprint, who was like renting dongles for $100 a day, and we were giving away signal for free. And so we got some great pictures of it because more people had laptops with wireless built in than something that they were going to be able to use with the Sprint dongle. I don't know what happened to that program. That was I forget what those dongles were anyway. So I'm going to hand this off shortly. This was a company called Green Wi-Fi. I'm not sure what they're doing now, but they were definitely running OpenWRT on that WRT 54. What else do I have? Oh yeah, so here's a picture of, we didn't have power at the on Mem Drive, but we did have plenty of sun. I have some pictures of our solar mesh projects here. We flashed OpenWRT into the Shiva plugs. Remember the Shiva plugs, the green plugs, and the plug plugs? So the plug business has kind of disappeared, but probably because those didn't have wireless on them. They only had Ethernet, and they had to stick a dongle, and we had those EddyMax dongles. So anyway, so we did plenty with solar. They don't have power outlets at the Mem Drive. There's another picture of the solar wireless mile. We advertised our SSID by filling up a weather balloon with helium, and it had had our SSID on there. So in case anybody thought this was some sketchy Harvard student serving up a man in the middle of, a vent out of their dorm room or something. Yeah, so now we're legitimate. So when people came over, they saw the weather balloon and they came over and associated with our.
Weather balloon does not prevent you from having a man in the middle.
That's true. But, well, yes.
Not to mention, how much did the weather balloon cost? Someone else could put up a weather balloon for their man in the middle network.
This is true. Sprint could have done it.
It's a lot of healing, that's for sure.
Oh, yeah, the healing is brutal. Yeah.
One of the OpenWRT, supposing Linksys is now embracing the OpenWRT.
Yeah, so.
Welcome Linksys.
So you'll talk about it, about the old bait and switch that Linksys did. So, what was the other company that's Cisco? No, they bought Linksys.
Then they spit it out again.
Yeah, and they bought Meraki.
And FlipCam.
Okay, yeah. Exactly.
Although after
Right, you're
Linksys did the bait and switch, they did regenerate it under a different name for the older hardware.
Okay, well, Brian, hopefully, for me.
I'll cover some of it.
By the way, the FlipCam guy is now doing a grilled cheese chain.
Oh, really? Is it like?
So it's a high-tech grilled cheese, but that's another story.
Oh yeah. Is it kind of like the RCA brand? So some Chinese company bought RCA.
Oh, no, it actually was bought by Thomas in France, and then, yes.
You want to do it, Tima? I could just do it.
You want to do it?
Yeah, I'll do it. See what you say, that way you can.
And I'll figure it out. All right. All right, when I do this, the side screen, right? There you go. I go ahead, I'll set up.
Kurt's got a great memory, and I had forgotten about the war drive. And so we actually did, and we were driving, as I recall, a van, I think. And literally the computer that we had this stuff running on, it was a big Dell kind of box thing that we had, plugged into an inverter in the car, right? It's amazing that, and we had all these antennas on the van, and we just figured that somebody's going to pull us over for all sorts of interference. But we had to literally, to get the kind of equipment at that time into the vehicle, we had to like take out the back seat of the van and stuff like that, right? Now it's got the equivalent of less than John's phone for sure. So I guess a lot has changed. And as I recall, the first system, first it was Kurt's kind of homebrew things that he and somebody else, you were always like, well, maybe Stephen Ronan, who's not here tonight. They were always flashing these things. Where did you get them? You got it for $20 or $10 or
Yeah.
Cisco or somebody was tossing them out the back door and he just got it back the truck up.
Well, City of Cambridge and MIT bought the Netgears by pallet.
Yeah.
Yeah.
So Kurt still has pallets of these things, if anyone is interested. And speaking of what's in the spirit of, Kurt's too much hardware and what to do with it, I brought along a few more modern, more recent vintage type things, which I'll talk about in due course. Certainly one of the, how many people are running OpenWRT of some sort on so less than a third actually. It's interesting. It 2 meetings ago or 3 meetings ago when Federico talked, it was like half the room actually was running OpenWRT. But anyways, all of these things are, they're 20, 30, 40, $50. You get into the higher end devices and, it's $160. And it's all a function. You asked about how much memory is in these, and we'll show you some of them. But it basically is, it's a Linux distribution for communications devices for, passing packets around of data wirelessly or over an Ethernet network, okay? So they're essentially specific purpose computers. They're general purpose computers that have a specific purpose of communications. That's what OpenWRT is all about. So, and in terms of what Bob was asking about, what's the subset or superset or, how do these things fall out? One analogy I've seen is it's kind of the bazaar versus the cathedral idea. So the idea is you build up the system that you want. So through the Kurt's things, the early generation was iPackage. Now it's OPackage, which is sort of the merged and a group as it's evolved. And we'll show some of this stuff. Chaos Comma is the latest version. So in the same way that distributions have release numbers or Ubuntu or whatever, this is at 1505, and every one has a different name and sort of set of ingredients that go with it. They do. Kurt talked a lot about, or some about the history of it. Well, we can cover more of that in a bit. One thing, and this will just be a little flavor of what it takes to get up and running on it, right? Is they have really great how-tos. Well, actually, one other important consideration. The earlier devices, they're all command line interface types of things. The newer devices basically have web browser interfaces for all the configuration, all the updating, all the management stuff. So you get better statistics, you get better, access to what connections and what leases are out there. But that comes at a price, and the price is typically more money. So the cheaper of these units, they'll run the browser user interface, which is called Lucy, just fine. But then you won't be able to load in, for instance, a compiler or Python or Ruby, and not all the components of the big Ubuntu or Fedora distributions have been compiled for the hardware. That's another important thing we can talk about. All these different devices, they're typically running different chips and different SoCs, and so the question is, has the Linux kernel, which is really just a true mainline Linux kernel, has it been compiled for that? That's kind of a starting point. And then the question is, have these packages been compiled for it? I have not, I don't think, apart from maybe a few things, I haven't done much in terms of compiling things right on these boxes, but you can, you basically can. So one thing, back to the how-tos, they're really good. They're step-by-step. The thing is, a lot of them are fairly specific. And I mean, unless you are a network guru, for me at least, having a recipe of do A, B, C, D, and E, and usually you can find a video of somebody who has done it. And at least in one case, I found a video of something I was trying to set up a configuration. I'll show you. And the reason he did the video is because he had to do this routine, but he could never remember how to do it the next time he had to rebuild the machine. So his way of doing it was, okay, I'll make a video for my own benefit. This is, speaking of videos, here's sort of, a list of videos we won't go through. We can pull up. This guy, Felix, is, he's one of the hardcore hacker dudes of the OpenWRT. He's been doing it for like ever. This is about an hour-long video, 10 years of essentially OpenWRT. Highly recommend it, well worth. You'll see his name all over the build notes in the latest releases. And I spoke with him once. He's in Germany or someplace in Europe. And he's been involved with all the OpenWRT conferences and things like that they've had for a long time. Okay, so this is obviously, kind of hardware for dummies sort of thing, but basically all these boxes is their little computers, and they all have SoCs, and they've got, memory, and they've got, some kind of network connectivity. Some of them have USB. Some of the USB is useful, like the bigger ones, for essentially network access drive types of stuff. Most all of them have multiple Ethernet adapters. So typically the way I use this is I've got some device that I kind of use it as like a front end. So and particularly the application is you got a bunch of little devices that are wireless devices that talk to this thing, and then this thing talks to whatever your office network is, or the internet pipe, right? The Ethernet pipe that you're going out to the big WAN on. And as Kurt mentioned earlier, that when we first did this plug stuff, and a lot of the plug stuff, the earlier incarnations of it was essentially just to get wireless communications or to get mesh networks. I'm not going to talk about mesh network. Have people done stuff with mesh network? Kurt and I is at least 2007 or before, where we were like compiling the open mesh code and stuff onto PCs, and this open-mesh.com is they sell these little boxes that are out there. You can get them fairly inexpensively, and you can set up your own mesh network very easily. And they also have nice user interface for maps. And Stephen Ronan, who's not here tonight, but he does a lot with inner city Boston, large scale developments, apartment complexes and stuff like that, where people share the net. On the hardware, so there's a bunch of different hardware, and I got a link. This probably isn't the best one, but they do a very good job in OpenWRT, and it's a good thing they do a very good job, because virtually every box that you buy has a different binary blob to go with it, right? And so people who have done this stuff, they're nodding, and so the best moves I made were I went out to this OpenWRT wiki, and I found out which looked to be the best supported, hardware devices, and then I bought those. It makes virtually no sense to me to take unless you really want to, kind of get in there and hack around for a long time. If you start with a piece of hardware that isn't well supported, you'll spend a lot of time trying to get it to do useful things. It's really, at this point in time, it makes a lot more sense to go to, as I'll show you, Amazon, pick one of the 6 that it seems to be well supported. This particular one, every device that they support, they do a really pretty good job of profiling in terms of hardware and processor, some speed information. And then another thing you have to be careful of, but not to overemphasize it, you'll have the same box, but it really actually has a different SoC, I mean, literally a different processor. So it's from the same vendor, but you literally have to go to the FCC ID. And in at least 1 or 2 cases, I looked at things, and the FCC ID is the same. You've got to actually open up the case and look at what the soldering sort of was on the board to make sure that and depending upon that, that's the distribution that you should use. Most cases aren't like that, but a few are. I'll just pull this up. I didn't bring, and Kurt will show you some of the stuff in a bit, but just to show you what the screenshots look like for, and this isn't great, but you'll get at least an idea of, essentially all they are is their web pages, and they spit out the information, the host names and boxes that are editable, you can edit, and this is sort of the Lucy interface. And it's the LU part is for Lua. Has anybody done anything with the Lua programming language? So in essence, that's kind of the native language of OpenWRT these days. Python is it's there, it typically is on board, but it's really huge. Lua is kind of small and light and fast and C-like, so it works well on these memory-constrained devices. The first thing I did, years ago when Ruby was just out, was to compile Ruby and get it running on this thing, but it was really bloated, and then it was like the only thing you could run. And it was like it was a really old box. So what I suggest is, if people who haven't delved into this are interested, I just buy a cheap box. You download the software and you spend a few hours kind of going through installations and poking around what the different, sort of what the different configurations might look like. We'll go through a few more specifics on that though. We talked about package management. It works just like, you do HTTP installs. It has a very nice way of just listing all the packages that are installed on your device, and it's pretty easy to do backup configuration. So once you get to a point where you have the essentially packages on it that you want, if you want to replicate to other routers, in essence, it's a pretty easy thing to do. Okay, so here are the devices that I have in the bin, and the top 4. I clearly like TP-Link stuff. It's well supported because of the chipsets that are in there, and I'm not quite sure if TP-Link has staff that works closely with the development team. But you've got a big range from $20 to $70, and with any of those, you can very adequately set up at least either a small office or a home base, essentially router network. And if you'd rather, as an added essentially security barrier to just the problem is with like home routers, for instance. I don't know if you ever had to call up whoever your network provider is, and they say, oh yeah, I noticed that you get 65 IP addresses on your network, and it's like, that's none of your business. So at least this way, some of the stuff you can essentially shape your own network in a way that's good. You'll notice that some have different numbers of antennas. That's if that's what you're interested in. Some of them have, you know, different sort of radios in them. But in this particular one, you get 2.4 as well as, you know, the 5 gigahertz. So it's really pretty nice. The cheap ones will just have one radio and that's all. The other ones will have multiple radios.
Fairly often, some of the better ones, you also have the ability to remove the antennas and potentially replace them without having to actually modify the hardware.
Yeah, yeah, that's a good point. I'm trying to think of what it is now. One of these, the naming conventions, it tells you whether or not the antenna is removable. You know, it's like the D on it or something like that is fixed. So it's a good point. Some of these they unscrew and some of them they're fixed on. I'm not quite sure what the cost savings would be there. But so then another one, and you know, Bob at some point can jump in. But so these are the devices. I basically got them all from Amazon. They're, you know, the prices are what the prices are. Readily available, highly reliable, and here's another one that you know, sort of one of Bob's friends, this guy Dave, who's done a lot with Wi-Fi and OpenWRT. He kind of basically said, "Why don't you get a real, you know, a real device, right?" So this is Linksys, and like Kurt was saying, the OpenWRT came from the original, you know, one of the original Linksys boxes. But so with this, somebody can look up what it is on. But you get, you know, you get gobs of memory. You get really fast processor. You essentially get a modern, you know, small computer in a box with rabbit ears for an antenna. So that's pretty cool. But going back a bit, those are the devices. And at some point, and Bob, maybe you can jump in. But so back in 2014. Or maybe even earlier, when did we do the first IoT Fest? And this guy, Jim Geddes, people know who Jim Geddes is?
Sure, yeah.
So let me just quickly run through his slides if I can find them. So he gave a talk at the first IoT Fest that we had, where he you know, talked about the importance of essentially security on these devices. And the simple observation is that most people are running routers that have, you know, software on it that's like 5 years old, right? So
That's the new stuff.
and that's the new stuff.
Yes.
Right, that's the new stuff. So it's really bad. I mean, it really is bad. And his whole point, and I didn't fully appreciate it when he first said it, and he gave all the examples of why. And the thing is, none of the stuff is updatable. You know, you're not getting any of the annoying update requests. The beauty of OpenWRT is you can just reflash it and you've got a new one. And they're coming out with new builds regularly. The new builds have new builds of the Linux kernel on them, and they've got, you know, sort of, they've picked up on problem areas that, so he put together the slide deck, which we'll give a link to, but, you know, the Internet of Things is wildly, he's talking specifically about the IoT types of applications, but he's got some, let's see if I can find it. John, you have a question?
Yeah, question about the updating.
Yeah.
No. Back in February of 2014, Jim Geddes gave a talk at that Internet of Things about a distribution called ZeroWRT, which is an offshoot of OpenWRT.
Right.
And that's since been merged back into OpenWRT.
It has been?
That's what I read on the ZeroWRT site when I was looking to upgrade. So my question is, I'm running ZeroWRT on a router right now. Can I upgrade that to OpenWRT without losing all my settings and have to reconfigure everything?
Boy, I don't know. I would say no, but you know.
Yeah, I'm surprised that at the merger, it'd be great if that happened.
I can actually point somewhere if you're willing to derail the talk to a certain extent.
Well, maybe we could talk about that at the brewery.
So there are two different distributions that, you know, John alludes to. So this ZeroWRT is, it was basically a spin-off from it with a focus more on, I think, security.
Buffer bloat research.
So this idea that buffer bloat, if people heard the buffer bloat stories, you know, basically it's just, there's a lot of extra crud that builds up in your wireless communications over time. And it's like memory leaks in software, you know, over time it accumulates and it impacts your performance. Why don't you explain it, Bob?
Okay, the way I compare it is, picture you've got a lot of people at a convention and you want to have them have fun. So Disney World is empty. And you keep sending people to Disney World and it doesn't fill up. And then suddenly you discover there were buffers inside every exhibit and everybody's got to wait an hour. And the problem is, and that's basically what the problem. Buffer bloat looks like the network is empty. TCP says send stuff, you fill the buffer, and suddenly you get hour delays. And that's an endemic problem.
So Jim told the great story of how he sort of personally, discovered that in the comfort of his own living room, basically. And so if Zero WRT kind of spun off on that, it looked like a lot of people contributed to that, but I personally have not installed it. So
could you spell that Zero?
CEROWRT. The problem is there's been no support for it, so it never quite made it to use by mortals.
I actually looked at their website back in either April or May to see if there was an upgrade, and it said that the project had ended.
Yeah,
and all the results of their work have been merged back into the main.
Okay, hopefully that'll do it, but that's why I put it on the side.
So some of it is, it's really technical stuff, but basically OpenWRT is a heck of a step up from probably what most people are running today, at least in their off-the-shelf, from maybe like a Verizon or somebody like that.
Wasn't most of buffer bloat actually more along the lines of kernel patches telling the kernel?
No, it had to do with, again, I don't want to claim too much of an expert because it was a messy thing to deal with. What really came up is, do you remember the big thing where Comcast started fighting with BitTorrent? That sort of broke the algorithms of the buffering. And that's when Jim and people sort of dug down to figure out what was really happening.
So the main message that Jim delivered was that, first of all, the stuff that we typically get off the shelf or that we're given when you get internet access, it's never upgraded. And it's all buggy, basically, and with security. Risk, and that you're much better off using one of these newer distributions that has addressed lots of those problems. Okay, so in general, the kinds of considerations that I came to think about when I got these different devices, how much memory, more is definitely better, because what you find very quickly is you won't be able to install the stuff and since you've got no hard disk on it, there's no paging, there's no nothing. It's either basically on the box or it's not. Price, which is a consideration, but they're all basically low. I didn't do any systematic sort of study of radios or frequencies or performance. I think they're all pretty reliable, And the thing is, when they stop working, it's the same as like your network, devices. It's to just get a new one. It's pretty much what it is. Compatibility and support is really important. And so, for instance, some of these devices are much better supported in OpenWRT than others. You spend 15 minutes looking through the wiki, and you'll get to it. This is just something that, what's a switch versus, a hub, and what's a bridge versus, and so it's just the terminology. What's routing versus NAT? And Bob and I and Dave, I kind of went back and forth on this a lot, and so. Sometimes the terms are used somewhat interchangeably or loosely.
The words are meaningless at this point.
Well, to sum it up, yeah. Okay, so one of the other things that goes on is this wireless battle, and it's focused on mesh, but what came out of this most recent one, which was just in the past month or so, was this observation about the FCC changing the regulations. Have people heard about this? Basically about locking down firmware. Is there anybody who sort of feels comfortable, wants to talk about it? I see some nodding heads. So the observation basically was that there is some new FCC regulations, there's new rulemaking. And it's not completely clear to me if this is, sort of proposed or in effect. Some indication was that for all systems built after June of some year, you basically you had to lock down the firmware, which would essentially prevent people from installing things like OpenWRT on top of them. So it's kind of like getting a locked phone that you can't just, pick up and take to a different country. Is anybody, yeah?
No, I just wanted to clarify. You're talking about blocking like the network level protocols, like I can run HTTP or not? Or you're talking about the radio frequency?
It's much more the latter in terms of the frequency and the power.
Because of the frequency and the power, but they're saying lock the whole firmware.
Okay.
Right.
But then you get the question, what's the firmware, what's the software on top? Basically, think 1968 before Carter phone.
So they're basically going to ban software-defined radios.
That's
the concept.
Yeah, that's the concept.
Well,
They're going to ban that.
in consumer creation,
devices that are under unlicensed operation. If you're a qualified licensee, you can use a software-defined radio. If it's a receive-only device, you can use a software-defined radio. But selling something as FCC Part 15 that's an SDR and has pluggable ubiquities it is dubious. It is seriously dubious.
Yeah.
I was going to point out, I'm not sure that you can go anywhere and get something that is not a software-defined radio nowadays, because basically everything is software-defined radios to some extent at this point. More likely, we're talking about ones where the radio firmware is much more difficult to modify, so you can't get it to do things like access the frequencies that are legal in other countries without some fairly difficult hardware modifications, potentially. And they're at least trying to make it much more difficult. There are going to be holes. It is going to be possible to break through the attempts at locking it down.
And people make the interesting observation that because so many of these things are manufactured, like, you know, in other countries and things like that, and because the complexity of the manufacturing process favors, you know, simplicity, you want one configuration. And since the U.S. is such a big market, if people have to build things for this one big market, it may sort of spill over into the other.
Yeah. This gets into a whole separate topic of if you make a mistake in 1927, you double down on it and detect complex licensed colors or not. So there's sort of a battle between, you know, the old idea that the radio is fragile and new thinking that we can program around that.
So it's just kind of more or less a heads up. The people who are really the gurus of this stuff find it really concerning, and in terms of what the time frames are, I think that it is a question. It's not likely OpenWRT is going to go well. In fact, here is, you know, one of Bob's friends, Dave, who, you know, basically points out
there are multiple days involved.
Yeah, that's right. Right. This is one of
that's the other day.
But, you know, but this pretty much sums it up. These FCC rules look bad. And this, you know, the other Dave had more to say.
He's actually David, so there's nothing.
Right.
But if it comes down to there's a wire you have to cut in order to make the firmware rewritable again.
The answer is don't ask, buy a Raspberry Pi.
Well,
so, yeah.
If they're really talking about making it impossible to put new firmware on it, then we're going to have to buy new products every 6 to 9 months because they're going to break.
No,
because the vendors, there's going to be, they do occasionally release new software versions to solve a problem on Comcast versus whatever.
Lock down with a trusted computing platform that only accepts the vendor's key, and we already know how to break that free.
Yeah. But actually, to be clear, I think one thing, and I'm not sure which it is, there are two parts is a lot of the Wi-Fi chipsets themselves, like Theros, used to be more programmable than they are. That's separate from the operating system. So locking down the radio does not mean you can't use OpenWRT, but that's just an operating system. So the real question is how deeply, you know, into sort of where the border is between the firmware and the radio or not.
But the FCC is saying that consumer level devices shouldn't be hackable either without the consumer's knowledge or without a competent engineer involved to make sure they aren't violating their frequency approval. Is not absurd.
Yes, it is.
There was a talk that Bruce Schneier did for the local ACM group, in which he described several disruptive technologies, one of which was software-defined radio. Disruptive because it empowers individuals to receive any frequency they desire with any modulation, whether or not a particular government might allow individuals to have that ability.
But the thing is, again, the reason it's just long discussion, the whole idea of frequency allocation is a weird legacy of a century ago's stupid algorithm. The way I compare it is you can only have 7 people in the room because there are only 7 colors, and if 2 people wearing the same shirt color, you get confusion, and you call interference is physics, and you can't do anything about it.
Yeah, spread spectrum takes.
And even beyond that, there's so many packets taken out.
So that maybe we can somehow bundle up a radio and, IPv6 kind of discussion for a future meeting or something like
Well,
that.
V6 is a whole nother.
We can keep going forever. Well, a lot's going on, and this, I think I updated this just a couple months ago, and it certainly has changed even more recently. This was the original. This is kind of the picture I wanted to get to, which is just sort of how I had things set up. Had these different TI devices that are Wi-Fi, and they're talking into this device. It's kind of edge nodes is what I call them. And then this OpenWRT device is connected here via a LAN address. Okay. And then the sort of little nifty bit that I want to do is I want to get these boards to be able to communicate with stuff on the internet, right? And so you'd think, well, what you should be able to do is just have this talk to this, and then somehow this talks directly out to, up top there was the gateway to the internet. But the way I actually had to set this up is I had to kind of set up this pseudo bridge thing, which the nice thing is there's a great recipe in on the OpenWRT wiki. And this was actually acting as a client to the gateway, which was up there. And this was basically connected physically to the WAN port on this into the LAN port on that. And so, believe it or not, by doing that, you can then get these little wireless edge nodes to talk out and communicate freely over the internet. And you think there's got to be an easier way to do this, and there must be. But actually, this is what it took. It took 2 OpenWRT boxes. This is basically like a server running on a local area network, and that essentially connected up to a cloud configuration. So all that, it took a couple of hours and of effort and under $100 of hardware at least for the router stuff.
One of the key points to make is you use from WAN port and the real question, are you a DHCP router or a bridge? And you can have as many bridges as you want.
Right. So that's a good question, right? So you can set these OpenWRT up to either be
or actually NAT versus bridge. Let's be not abuse the word router too much.
Yeah. Bob and I went through round and round on this like a lot. The natting and the bridging, and actually, Bob, this is what came from that, right? Which was that was my whole objective, which was how do I get these little devices which are on my local network talking out over the internet, right? And so the way I needed to do it was wirelessly have it talking here, and of course all the stuff was then within my. But the other thing I wanted to do is I wanted to isolate this traffic on this local wireless network. That was the other thing. I mean another.
You have multiple levels of nets.
Yeah, exactly. So what I easily could have done, I could have had this one just talking to the gateway, and then that's talking to. But I didn't want to do that. I didn't want to have these devices, back to the scenario of you call up Verizon and tell them, oh, it's interesting, you've got 86 IP addresses on your network. Well, I didn't necessarily want them to, have any interest in that, right? So
they can't tell them anyway.
Well, they're pretty good when
only if they supply the router.
Bingo. Yeah, right. So which is what this little thing with the red Verizon
logo. You don't have
to
use those.
No, you don't have to use those, right? How many people use those?
I use it as a bridge.
Yeah.
Not as a DHCP server.
Right. So okay. So your point is that if you don't use it as a DHCP server,
turn it into a bridge
that's
and put your own DHCP server.
Yeah, that's a good point.
Is that the Action Tech?
Yes.
It is.
They tried. I just had it FiOS installed last month, and they tried to ship me that, and I rejected it and went for their new quantum router.
Oh no, it's the same thing. The box is about the same, but you can turn it into a bridge.
Okay.
But make sure again, there's people on your own.
Supports AC, and the Action Tech does not.
Okay, but on the ONT, if you want to do your own, make sure they give you Ethernet off the ONT.
Okay. I think I do have that.
So as you can tell, once you go down this path and you start, tweaking, your own like wireless networks, whether it's your office or or your garage or wherever you might have these things, it can get fairly involved fairly quick, And the thing is, once things stop working, everything stops working.
Throw in one more thing, by the way.
Sure.
The latest Google thing, they're now throwing two additional radios in.
And what does that buy you?
Okay, one is the Bluetooth thing, which we won't go into.
Yeah.
The other is the Zigbee radio repurposed as a thread radio, using a different packet protocol on called Thread.
And what's Google? Are they actually selling one of these
The
boxes?
TP-Link they just announced has
Okay.
all the 3 radios in it.
Interesting.
Is that what the thing for Project 5?
I think it's part of the larger picture, but it's more for the home control. Now, home control has 2 meanings here. One is home control, you're in control. Home control, the other meaning is they're in control, and we'll see how it plays out.
So is there an availability on that?
They just announced it, I know.
Yeah, like today then.
Yes.
Really? Okay. Well, very time. Oh, so we'll add something in on that. Yeah, Bob. Anything else to say on the thread stuff, Bob? Because we've talked about that.
The main thing, this is whole separate discussion, is it's a security perimeter. So have fun with your Trojan horses. You can throw attacking systems.
More on that. We should do something on that in the future.
Brian,
Yes.
what was the pseudo bridge for?
I'm looking at this. This sort of explains it, but so the pseudo bridge is it's like not really a bridge, but so this is acting as a client to this gateway, okay? And the way it's connected, and by this being a client to that gateway, I believe what happens is it picks up, well, as you can see here, it gets an IP address on that.
You could have got it directly.
No, you can't, just because either, and I'm not sure why, it seems like you should be able to, but you can't.
Looks like he's triple natting, which gives him 3 opportunities to get a 10 address that will be broken.
Well, the other thing is this is on a different subnet, which is what I wanted. So that this is on 6.1 and that's on the 1.
Right, what I'm wondering is why is Edge router not plugged into gateway?
Yeah, just use it.
Why is this not plugged into gateway?
You could have put, what he's saying, you could have plugged the edge route directly into the gateway.
Yeah, but you know what?
It's not worth debugging here.
No, it's a homework assignment. I challenge anyone to do it because I certainly would have done it. I tried. And either I'm not quite sure why either OpenWRT doesn't support it or, I couldn't figure it out. But the way I did it was I had to do this multiple hop thing.
And this is why we need to redesign the
Yeah. All right, I gotta get off the slide. Anybody know about the Moose Madness malware? Everybody sort of been afflicted by this? So this is, you can read up on it, but this is a case where basically there was a malware virus that had essentially embedded itself into, routers, and it's pretty bad. And what they found from this Moose malware actually is that what it was doing is it was rerouting traffic to these, kind of social networking sites. So it wasn't like it was going to banks in Romania or anything like that. It was, for whatever reason, it was like driving traffic to. So this
advertising
for advertising. The monetary incentive was essentially. Okay, I'm going to run through a couple of these things. So this is Dave, one of Bob's friends, and he just really knows all this stuff. And so I asked him a bunch of questions. I was curious, which routers actually just ship OpenWRT, And his response was basically lots do. And most are shipping older versions, but, and if you want to go to Alibaba, just search on OpenWRT and you'll find, what's Alibaba? It's like a Chinese version of Amazon.
Yeah.
And Hangzhou is Boston's sister city, putting a good word for Hangzhou.
It's like a way of buying things directly from.
The largest internet beachhead in the world, right?
Yeah. So
So it does both wholesale and
eBay and Amazon.
Yeah, question about.
So is there a question, in this room, how many people have watched from Alibaba?
How many people have bought stuff from Alibaba?
There are also companies like Taibo, which
A handful.
you also have many in the box and
Yeah.
all these places are resellers off of Alibaba.
Yeah, yeah. It's the hardware is, you know, widely available, and the question is, when you get it, you know, what really you get, and it can be kind of hard to tell on some of these things, but.
But that's what I'm saying.
That's where the ISO standards go.
So there's 1,000 listed on the OpenWRT table of hardware page. So all of these are flash.
Oh, okay, there you go, yeah.
Oh, TOH page.
Yeah, did they give any prices on any of those?
Well, I don't know why they're putting tech data down as the vendor. Is this for like resellers or something?
Yeah.
Yeah.
No, okay.
Yeah, there's a lot out there. Okay, let's see.
Tech data, wait, which one were you?
No, I misread it. So device, so that's the PDF to the device schematic, I assume, right? Let's find out.
Excuse me.
Yeah.
This was the question about, and for some of these things, you know, unless you're doing it for commercial applications like, you know, restaurants or hotels or office spaces, or you know, for the person who just wants to experiment with this stuff, you're not going to get into this. But Dave is doing this on a commercial basis, and so he knows all the ins and outs of it. You don't really want to see this stuff because it's pretty generic. I think that's about it. So any questions or?
I would add the comment to your page, but well, watch out for the hole.
Watch out for the mouse traps.
Yeah, but your thing about finding a wireless frequency that no one else is on. Additionally, make sure to only use frequencies 1, 6, or 11 because you're evil if you use any but those 3. Well, there's also the other frequencies that you're not supposed to use in the US, but in the US, 1, 6, and 11 are the good ones.
So maybe another option on that is that, you know, as you start to get into this stuff, you can mess things up that make it life inconvenient for you or your neighbors, or you know, and that's maybe gets back to what the FCC is sort of challenged by, which is how much freedom do we give people? And
No, FCC is how do we keep us in the 19th century?
Right. Kurt, what do you think? You gonna do it?
So I've got these are notes back in my office which you can access. You see the MIT IP address there. I just got that when I stuck the Ethernet cable in. You guys are more than welcome to SSH.
Water on both screens?
No, this will be okay. I think we'll bring other stuff up here.
No, so on that screen, it's not going to be picked up at a camcorder.
Well, I was just going to give out the root password and people can log in. So keeping in the long tradition of having remote access with root. So and of course you can find the RoofNet root password if you subscribe to Wired magazine, I guess, or certainly it's all over archive.org. But I just wanted to show you, and we don't necessarily have to belabor this. So one of those boxes is the OpenWRT Backfire, which might be the most recent OpenWRT. It's got a 2011 date on it, and then the Cambridge Public Internet box was like a Gen 1 OpenWRT. That's got a 2006 date on it. So and I got another box up there. You can see from the when you have a Meraki IP that begins with a 5. Only Meraki boxes can see that. That's not beaconing or anything.
That's a Hamachi network?
Pardon?
Hamachi?
Hamachi?
The whole virtual IP network that logged me in people.
Oh, so they're using the, here, let me do, this will blow your mind here. I'll do a quick config. So look at all the devices you get on these things. You get over here, you'll get something called an SRCR device, which is a clip router device. So these guys are all talking to each other and finding what kind of.
It's fine with virtual overlay on the internet.
Yeah, RoofNet calls them VAPs, I guess.
Yeah, and I think this is part of the whole thing that login people choose, which liberates you from a lot of the constriction of the standard internet.
Yeah. And it's funny, this thing, you're sitting there waiting for your IP address. It is out there. LS modding, and so it's taking a little while to configure and dialing back your signal strength and stuff like that to find out where your nearest nodes are and how much bandwidth it can pipe through the close ones and distant ones.
So
And then-
Kurt, what's it doing with all those different devices up there?
So
What does it need them for?
So a lot of so there's only 2 or 3 devices that you get to see. You'll see there's on the one SRCR, like I say, the CR stands for Click Router. So RoofNet uses the Click Router, which is another project at the CCL PDOS subgroup. The only SSID you'll see if you walk in with 2.4 gigahertz radio is RoofNet. You can associate it with it and start getting internet access, or you can't. But all these other SSIDs are not beacon, so you won't see those. They're just to talk to other RoofNet nodes. And it's pretty much a stock OpenWRT install, except for the TCP/IP, the IW config stuff.
Although I look at that gigantic long list and wonder how many of those are virtual interfaces tied on, and how many actual real interfaces does it have?
Yeah, like
That's the problem, dynamic routing. What's real?
And there's any kernel modifications?
no. Like I say, this is just all userland stuff sitting on top of a stock OpenWRT. 2.6, I think, in everything I've seen from the old version of OpenWRT. Do you know what kernel like that now? Yeah, even this one, this guy here, even the 2011 variety is 2.6.32. So I don't know if they ever got up to 3.
It's also dependent on Broadcom. I think even in that backfire, some of the Broadcom stuff was 2.6 and
Oh, really?
You're talking about kernel versions?
Yeah.
I was just looking that up. I think they're currently on 3.18.
Really?
Yeah.
Which is actually a question I was going to ask of you guys. One of the issues I've had with getting into this is that they always seem to be running ancient kernels. I know it's often because of device driver issues and binary modules and stuff like that. Is there a set of hardware which has fully open source drivers so that there's a possibility of actually following along with current kernels? Or are all of the devices that people are using for the OpenWRT at some point going to get stuck because they're using some binary driver from the hardware manufacturer?
Most of them you can get more recent drivers for, though you will find that something that is officially an OpenWRT release is going to have a somewhat older kernel, because basically it's going to lag behind the development branch by some ways. Certainly the development branch was at least on 3.18 last I checked. It may well be past that point now. And many devices can run those kernels. It's just you're not going to see that in a release branch.
It's a good question. You're right. 3.18 is the is kind of the latest. So, but I'll ask actually and just add it to the post meeting wrap up.
And it's years.
That's a good question.
Years between distro releases too. I mean,
What?
Sure.
Yeah.
One additional comment I would make is the OpenWRT folks, they have got their sort of switch configuration, basically kernel patches. They have been maintaining them outside the kernel at one, I believe they are, I suspect they are still interested in getting it merged into the main kernel, but at least for the main kernel, there were some criticisms of the way they were, the architecture behind that. Problem is that I kind of got the impression from what I was reading that it was basically the folks behind OpenWRT and the sort of core kernel maintainers had different viewpoints, and they weren't trying to get the things settled between them, which is the switch configuration stuff outside of the mainline kernel. Though I believe DDWRT has picked up on OpenWRT's switch configuration architecture and is basically running it on their kernel as well. It's just you're not going to see this in the mainline kernel because there's criticisms of it, and OpenWRT, I think as I say, got under the impression OpenWRT had good criticisms of the criticisms, and they weren't trying to sort of get everything settled, and so it's probably going to remain outside the mainline kernel,
It
at
sounds
least
like
for a while.
It's a good question. Just where do the mainline kernels and the OpenWRT kernels, and Bob had early questions on this tonight too. So we'll we'll dig into it. And my sense was it's pretty good harmony between the different essentially teams of people. And so whether it's just pragmatic, the challenge of churning new releases out, and but are there any technological impediments or otherwise? I'll follow up on that and check. What are the questions? Yeah.
So you mentioned DDWRT. What is the relationship between that and OpenWRT?
Anyway, so what's the relationship between DDWRT and OpenWRT? So I mean, I believe
The kids these days.
So I'm pretty sure DD came first.
Yeah, right. So it's just an earlier generation of it, and
so that's still being developed, or
DD-Word is very much currently being developed on more recent versions. As I say, I was actually looking at some of the stuff, and they actually were making use of OpenWRT's kernel patches because they got all the work done. And
I may be completely mistaken on this, but I think the history of it is that DDWRT was actually developed by Linksys in-house. And then when it went truly open,
Linksys Linksys was using Linux
without
and they had to distribute some of the source code, and other people picked up that, including the binary drivers that Linksys had made, and they basically reverse engineered how Linksys made their firmware images, and they started adding things to the firmware, and that's basically why it was DDWRT, because it was based off of originally just Linksys hardware and the original Linksys source code. But my impression is that DDWRT has kept closer to what the hardware manufacturers distribute and added things to it. Whereas OpenWRT was, we're going to start with as much of a blank slate as we possibly can, and build up what we would like in a router operating system from the various pieces. That's my personal impression.
Yeah. And I think that video I mentioned by Felix, the 10 years of hacking and this stuff, I think he actually goes into pretty good clarity and depth. I mean, he was there on the front lines, I think, as well. Yeah.
There is this thing called ZigBee which was mentioned, and there is a standard called 6LOW band, which is supposed to be run on the same sort of hardware. Does anybody know anything about if that's progressing?
6LoWPAN. One of the things I showed on these little TI boards that are they're providing support for those different.
This is essentially the Google thing would be using it for the whole thread thing. But I mean, again, I don't want to get into my strong opinions on you know, there's a lot of complexity here in the current net purpose, trying to stretch it out for its purposes. And let's say it's been stretched beyond the original design plan.
Is that 2.4 gigahertz?
What?
6LoWPAN?
No, 6LoWPAN is about saving bits for small edge devices.
Oh.
So that if you have a ZigBee radio and you have 64K address space, it's a way to connect with IPv6 and sort of you get the local sub-address that speaks to IPv6 devices.
If you look up the TI stuff in 6LoWPAN, and Simple-Link, you'll probably find either boards that are available or will be available in the future. So low cost types of thing.
Kurt, what was the name of that company with the radios that you could exchange?
So Ubiquiti is the 800-pound gorilla in the radio business right now. I don't know anybody that doesn't use them that needs to swap radios. Yeah. I mean, having it soldered in there is cool and it keeps prices down. But if you need a long-range, high-power FCC Class B legal radio, the Ubiquiti is the way to go.
Thank you.
And the prices tend to be pretty really good too. Yeah. Good price quality.
I'll show you some of their. They've got so many products.
What else? Any So I guess the kind of the bottom line of some of the stuff is that the hardware is inexpensive. It's really reliable because it's all benefit from the mass production probably that's spun off from phones and stuff like that. The software is now it's really later generation stuff. So a lot of the common bugs and impediments are we're way beyond that now. It's easy to customize to your own likes and dislikes, and it's kind of neat. You can get in there and you can do low power stuff. You don't have any boring hard drives. So if you've got little utility kinds of projects that you want to build out, these are great ways to go. And years ago, you really had to make hard choices on, gee, do I want a C compiler on there, or do I want Python? Now you've got really powerful devices for under $100.
Question: these are all reflashing off-the-shelf routers. There's a whole generation of like Raspberry Pi, Arduino-based devices. Have you had any experience with those as routers?
You mean sticking a radio in there somewhere?
No, when they come with radio, I mean, they're now very inexpensive packaging of Raspberry, again, the Pis, the Arduinos with radios that are basically ready to go. I haven't, had a chance to play with the price, like $10 and things.
So the question is, what's your IP stack? What's the software? What's
Maybe
your
I mean, I haven't explored this. I'm just seeing the mention of this.
So what that kind of strikes me as is what we went through with OpenWRT 10 years ago, maybe, right? I mean, that's kind of what I'm feeling, that you probably can do hello world kinds of level stuff, but to actually deploy it in
no,
they run Linux.
No, these are full. I mean, it's like these are they're putting full Windows on those machines. So one of these time warp things I'm feeling when you mentioned 8 megabyte devices. Where do you get devices with that little memory? Is the router world stuck with very ancient hardware? And because it's a low price Pi and things are so much more powerful.
Yeah.
I think you would. Well, opinions may differ, but I kind of. It might still be possible to get some El Cheapo network routers that have only 8 megs, but yeah, that's pretty low nowadays.
So I'm wondering whether there's a time warp here that we need to catch up with the new hardware.
Typically, the non-volatile flash is 8 megabytes, and it doesn't span to 16. They'd have to add another 8 megabyte chip. I don't really know.
Megabytes, not gigabytes.
Megabyte for
the
operating system. So typically, you'd have to write a driver that spans across 2 of them to get the full 16.
No, I understand it's using that hardware, but it's like, how many of you can buy an SD card that's less than 8 gigabytes?
So you would be running a NAND system, so those you can get like 128 or a gigabyte on a router, like a Raspberry Pi that had a mini PCI Express, the SSDs. But it's different flash though.
No, I understand that. I'm just trying to understand the design point of all OpenWRT versus today's hardware.
Well, I think one big difference is even if a Raspberry Pi has a radio in it, it's designed to be a client, not an access point. It probably doesn't have as many antennas. It may have as strong a transmitter receiver. It may not be AC. It may only be B or G, LC11B or G. It just doesn't have as much on the radio side as a purpose-built router.
No, I understand, but there just needs to be more. The cost part, why would the purpose-built ones basically be generations behind in the hardware?
Technically, it's not though, because you can still expand your disk space if that's the concern to USB.
No, I understand. No, what I'm saying is all this OpenWRT here is designed to run machines that are the best, most inexpensive machines from 10 years ago.
So I suspect that, say Netgear, for instance, there's
licensing too, right? The licensing.
Well, they will buy the entire run of a Toshiba DRAM and come out with a Netgear WGT something, and then immediately discontinue it.
Yeah.
So I think they're buying off of gray market pricing, and that's why. So they're getting these single DRAM chips for
No, again, I don't want to relate
I
this.
believe I think you're going in you're going in different directions. His point is why are you still targeting 8 meg devices? And the answer is that nowadays I doubt there's very many devices with that little
on the contrary.
DRAM on them now at this point. On the other hand, I believe nominally OpenWRT, I think, supports devices that small, but I doubt you could buy anything with that little.
So this
now.
is, again, I don't expect to get the full answers here, but the thing is, I'm learning a lot here, which is generating these questions of trying to understand, you know.
I would say it's a matter of simple economics. These chips, like the SD card that I was hacking into a couple of months ago, they are SoCs. There is a cost to the IP of what goes into the SoC, so they tend to be older ARMs, and there is a cost to the size of the die and the chip. So given that you can build an embedded system very effectively with 8 megs of permanent flash, and then after you expand out of there, you have the 16 bits of flash over in the other chip that are not permanent and can be rewritten, but they are available to you. It's the most cost-effective thing that the vendor can do, because then the chip will just cost a single number of dollars.
No, I understand. I mean, I understand there's extreme cost pressure in all these.
Yeah.
Again, it's just when I'm carrying $99 device.
Right, exactly.
Are you sure there is no subsidy in that $99 device?
This one, and you've got the same thing. This is unlike the phone. This has to be sold as a standalone device.
Yeah, I remember, what was it, Vonage or something, that people were like hacking OpenWRT in their Vonage APs and violating the terms of service.
Well, violating terms of service is something every freshman in MIT should violate some terms of service just to get used to doing it.
All right, what else? What other questions?
I would actually point out there's one. It may be very, very small, but one Linux distribution that you haven't mentioned in the world is DebWRT.
Want to talk about it? Describe it?
Well, this is basically more or less what it's targeting is aiming. It more or less uses OpenWRT as a bootloader, and it's simply running the Debian distribution. The small number of packages, they're rough equivalents of what's in OpenWRT, so you can run Debian on a wireless device. I find this nice because I'm used to dealing with Debian, and I think it's slightly better architected for doing security updates.
So these are devices that have enough memory to run through Debian.
Basically, none of them do. What it is a number of devices have got USB or SD card slots, and you can add enough memory that you can run.
That's a RAM requirement.
Yeah, part of that. One of the things it's set up to do is basically it's expecting that you'll have either USB or SD card on there, and expects to allocate some of it as doing swapping to flash, which some of us cringe at doing, but on devices that have got maybe as little as something like 16 or 32 megs of memory, you have to be prepared to do that.
Question in the back?
Yeah, hey, I had a kid watching the stuff about mesh networking and the root net about like a decade old. I remember doing stuff like that. So I wanted to talk about like mesh networks stuff. Maybe like after at the pub or something. I wanted to recommend a distro that's OpenWRT too. It's a package that goes with it. It's called Meshbox. So you even brought up like Lucy and all some cool stuff. So programming that and doing like again mesh networking stuff.
Yep.
Yeah.
So the idea with mesh networking is too that we the idea you can have different devices that sort of hop the communications from one to the next to the next to the next, and you kind of share almost a serial pipeline of communications. That's gross injustice to the technology, but that's sort of roughly the idea. Whereas all these things are essentially point to point. It's more kind of hub and spoke.
Yeah, the drivers have come a long way. I just want to add 2 cents.
Yeah.
The drivers, the F9K drivers, you can do the same channel, but you can do as a client, as a station, and as a mesh node simultaneously one router. One
I believe
physical. So it's come a long way.
Yeah.
I believe most of the wireless devices you can potentially do that. It is a case of finding the appropriate tools to do it. I think like on the Broadcoms, you can actually do that. You just have, it's just, if you're using the Broadcom proprietary driver, which unfortunately supports far more hardware, you have to use like their specialized tool to do the equivalent of that, but it is doable.
Yeah, I've never really kind of got it quite straight whether the mesh network stuff is it just all software or is there really any hardware, Matt? You know, like you're talking about the access point, and you know, is it all just, is it hardware or is it really software? You know, it's just a radio is a radio.
Well, except it depends on the performance. You have to have multiple radios if you really want to relay quickly.
Yep.
I don't think my guys are using Ath9K, and even my 2011 box, I think it's still the old Athros driver. Whatever that was. Yeah.
What are you looking at here, Kurt? Can you just maybe run down roughly what these screens are?
Yeah, so these are this is, one of them is this box. One of them is this box. The other one is this box. So you'll see that the one plugged into, actually I've got 3 boxes up there, I must be logged into the wrong one. So one of them says gateway false because I didn't plug the Ethernet jack into the wall. This guy says gateway true. So that one is, if you were walking around my office right now, you could associate with SSID RoofNet and get internet access. It would be much crappier than MIT's wireless access, but you know, and you can set the default channel. This is 2.422, which is what, channel 1 or something, channel 6, and this page, you know, would change if I plugged it into Ethernet, it would change the gateway to true. I'm not sure why my uplink IP address is that. Anyway, tells you, if you remember from my slide, I had one RoofNet node that had 50 routes. This one only got 1. It is seeing this device over here, 5.14.92.68, is being seen on the .77 box, and it's generating those IP addresses from the MAC address somehow. It's just they're addresses that the consumer will never see. You'll see an SSID and a routable IP address. And in the city of Cambridge, everybody got a little nice DHCP pool of 255 addresses. 10 address, and you'd be driving down Mass Ave, and you'd be transiting between APs. Yeah, so that was one way to do it. I know Lincoln Labs had mobile mesh, and they were handing off different IP addresses.
Again, this gets into working around what needs to be rethought.
Yeah. So, because we did all have to come back to one, you know, we had to maintain our DHCP leases.
Again, this is a long discussion.
Yeah, okay. Which is beer will supplement that.
Okay, well, good discussion, okay. Jerry. Thank you very much.
Thank you very much.
Thanks, Chris.
Okay, one more. Okay, let me have a show of hands on who now plan to go to the Cambridge Brewery. Okay, 1, 2, 3, 4, 5,
how far away
6.
I'm going to drive.
7.
It's version of Kendall Square V2.
So we got.
If you've been around long enough, you know what I mean.
8 or 9. Okay, 8. Okay.
If you
Now, who is going to walk?
I'm going to drive.
Cody, okay, we got 3, 4 walkers. And no limit. Okay.